Bright QT. Every student matters.
In this given figure, AB is diameter of the circle. So whenever you get the diameter, whenever you see the diameter in a circle, you always visualize that this angle, that is angle in a semicircle, will be a right angle. Okay, so AB is diameter. By just looking at this, I can simply visualize that this angle will be 90 degrees. Okay, so this will be my first observation. CD is a chord equal to the radius of the circle. Now look at this concept. If you have got a chord which is equal to the radius of the circle, let us say this is the chord and this is radius r, so this will also be r, right, if this is the center, and chord is given equal to radius. So whenever a chord equal to radius is given, then you can simply visualize that this angle here will be 60 degrees. Why? Because this is an equilateral triangle. This side is equal to this side is equal to this side. Okay, so a chord equal to radius will subtend an angle of 60 degrees at the center. So this chord will subtend an angle of 30 degrees at the remaining part of the circle. This should be clear to you in your mind. Okay, CD is a chord equal to the radius of the circle. So this angle here is 60 degrees, right? AC and BD, when extended, intersect at point E. Prove that angle AEB is equal to 60 degrees. That is this angle. We need to prove that theta is equal to 60 degrees. Okay. Now let us look at this. So now look at the chord CD. Chord CD subtends an angle of 60 degree at the center. So it will subtend half of 60 degrees at any other point. So chord CD subtends angle of 30 degrees at point B. Okay. Now we know that this angle is 30, this angle being 90, so this angle will also be 90. Now in this triangle CEB, one angle is 30, one angle is 90. What will be this angle? This angle will obviously be 60 degrees. So what are the arguments that we will give here? Number one, angle ACB is equal to 90 degrees because angle in a semicircle. Second argument we will give that angle COD is equal to 60 degrees because triangle OCD is equilateral, as CD is equal to OC is equal to OD. This I have already explained to you. Now angle CBD will be equal to 30 degrees because chord CD subtends an angle of 60 degrees at the center. So it will subtend half of 60 degrees at any other point on the remaining circle. So you will write the complete statement here. So CBD is 30. Now angle BCE is also 90 because it is linear pair of angle BCA. So once this is written, then you can select the triangle CEB. In triangle CEB, by angle sum property, theta plus 90 plus 30 is equal to 180 degrees. Hence theta is equal to 60 degrees, and this is what we had to prove. Okay. Again we are given a cyclic quadrilateral in which AC and BD are its diagonals. Okay. Angle DBC is 55 degrees. So let us write it here so as it is easy for us to visualize the problem. Okay, angle BAC is 45. BAC, that is this angle, is 45. Find angle BCD, that is this angle. This is what we have to find out. So if I ask you a question that if you know about angle A, if you know measure of angle A, can you find angle C? Yes, because it will be 180 minus angle A, as the opposite angles of a cyclic quadrilateral are supplementary. Now look at chord CD. It subtends equal angles at B and A. Hence, angle CBD will be equal to angle CAD equal to 55 degrees. What that means is that this angle is 55 degrees. Now you know the measure of angle A, so it is very easy for you to find angle C. Angle A plus angle C is equal to 180 degrees. Opposite angles of a cyclic quadrilateral. Right? So what will be angle C? It will be equal to 180 minus angle A, that is sum of 55 and 45, which is 100. So 180 minus 100 is the measure of required angle, angle C. So angle BCD is equal to 80 degrees. Right? Two circles intersect at points A and B. AD and AC are diameters of two circles. So whenever I see a diameter, I know that this angle here, angle in a semicircle, is going to be 90 degrees. And AC is also a diameter, so this angle is also 90 degrees. Right? Prove that B lies on the line segment DC. So obviously this B, at this point B, angle subtended by AD is 90, angle subtended by AC is also 90. So this being a straight angle, I can say DBC is a straight line, or in other words, I can say B lies on the line segment DC. So in this question, you don't have to do much. You just say that AD is diameter, hence angle ABD is equal to 90 degrees. You will write the reason: angle in a semicircle. Right? Then you will make a statement that AC is diameter of this circle, hence angle ABC is equal to 90 degrees, and the reason is angle in a semicircle is a right angle. Now angle ABD plus angle ABC is equal to 180 degrees, hence a straight angle, and because of which we can say B lies on line segment DC, because it has to be a straight line. Only then these angles, some of these angles can be 180 degrees. Right? This was a simple one. Prove that the quadrilateral formed, if possible, by the internal angle bisectors of a quadrilateral is cyclic. So let me take a quadrilateral here. Let us say this is quadrilateral ABCD. So if I take internal angular bisectors of angle A, angle B, and angle D, and angle C, they form a quadrilateral inside. So I am talking about this quadrilateral P, Q, R, S. And if they do so, then this quadrilateral PQRS is cyclic. This is what we need to show. So would it be enough to show that if sum of these two angles is equal to 180 degrees, then this quadrilateral PQRS is cyclic? Yes or no? Yes, it is enough, because if we can show that opposite angles of a quadrilateral are supplementary, then this quadrilateral will be a cyclic quadrilateral. So it is enough for me to show that angle S plus angle Q is equal to 180 degrees, because once I show this, it will automatically be proved that angle P plus angle R is also 180 degrees. So how do I go about it? Now I know this is angular bisector of angle A. So if I only talk about this angle, this is half of angle A, right? If I talk about this angle here, this is half of angle D, right? And if I can name this angle as angle theta, so this angle will also be theta because this is vertically opposite. So in triangle ASD, angle A by 2 plus angle D by 2 plus angle theta is equal to 180 degrees because of the angle sum property, because angle sum property. Now let us talk about this triangle here. Let us say this angle is beta. So what will be this angle? This will also be beta because of the vertically opposite angles, and we know this is angle bisector of angle B, so this angle is half of angle B. Similarly, this being the angular bisector, this is half of angle C. So in triangle BQC, angle B by 2 plus angle C by 2 plus beta is equal to 180 degrees, right? Once I know these two things, now I'll add these. So angle A by 2 plus angle D by 2 plus angle B by 2 plus angle C by 2 plus theta plus beta is equal to 360 degrees. And what can you say about this sum? We know that sum of internal angles of a quadrilateral is equal to 360 degrees. Angle sum property of a quadrilateral. Angle sum property of a quadrilateral. So half of A plus B plus C plus D will be half of, it will be 180 degrees. So this sum here is 180 degrees. Hence, if I take it on the right hand side, theta plus beta will be equal to 360 minus 180, that is 180 degrees. Once I have shown that this sum of these two angles is equal to 180 degrees, I can say that quadrilateral PQRS is a cyclic quadrilateral, because if theta plus beta is 180 degrees, angle P and angle R, sum of angle P and angle R will also be 180 degrees. So PQRS is a cyclic quadrilateral.